Hello everyone, welcome back to this video series on SDTM programming with R for clinical SAS programmers. In this series, we will see how to implement key SDTM programming concepts using R. We will take a quick look at the SAS program for the same concept and then see in detail about the R program. Please note that the complete explanation of SAS program for this concept is available in a separate playlist. I will leave the link for it in the description of this video. So in this video, we will see how to create RFICDTC, RFSTDTC, and RFENDTC in SDTM demographics domain. So on the left hand side of my screen, you see the SAS program that is used to create these three date variables, and on the right hand side, you see the R program that is used to create the variables. So let us take a look at the specification for this video. So here we are creating three variables: ICDTC, RFSTDTC, RFENDTC. So date time of informed consent, subject reference start date time, subject reference end date time. So for RFICDTC, the derivation says populate using enrollment dot ICDT underscore raw. So we are being given the raw date value from the dataset called enrollment to be used to create RFICDTC. So as DTC variables are expected to be in ISO 8601 format, so this is inherently specified that we'll have to convert this date value into ISO 8601 notation and then assign it to RFICDTC. For RFSTDTC, we are being asked to check for the subjects who took at least one dose, populate using earliest IP admin IPSTDAT raw, otherwise populate using enrollment rand dt raw. So we'll have to inherently check for two different date values. One is IPSTDT raw from IP admin dataset, and the second one is rand dt underscore raw from enrollment dataset to populate RFSTDTC. And let's see the derivation for RFENDTC. It says populate using eos.eostdt underscore raw. So again, this is similar to RFICDTC. This is coming from directly from a date variable in one of the datasets, which is EOS in this case. So let us take a quick look at the input datasets that we have. So let me zoom in a little. So here we have our demographics dataset, which has all the records for all patients who are participating in this study, and the variables are study, PT, and some other demographic variables like sex, ethnicity, and race are present. So we are being asked to use IP admin to populate RFSTDTC as one of the components. So we have that input dataset. I don't think we have. Do we have? Let me open the other file which may have all the input dataset. Yep. So IP admin is present here. We have records for each dosing that the subject took, and we have enrollment dataset in which we were asked to use ICDT raw for RFICDT and RANDT raw as one of the components of RFSTDTC. If we take a look at the date values present in these variables, so they are not in standard ISO 8601 notation, so we'll have to convert them accordingly before using it for the derived variables. And then we were asked to use EOS dataset for RFENDTC, and the variable was EOSTDT underscore raw. So we will be using this dataset and EOSTDT raw variable for RFENDTC. Now we took a quick look at the input datasets as well. Let us jump into the programming explanation. So we will first take a look at the SAS program and then move on to the detailed explanation of our program. So what we are doing here is we are using IP admin dataset, creating a new dataset called IP admin 01. Within this, what we are doing here is we are checking whether the IPSTDT underscore raw is not null and creating a new numeric variable called IPSTDT raw by converting this raw date value into numeric format using input function and date11 in format. And then using that date value and converting it back into ISO 8601 notation, which is equivalent to YYMMDD 10 dot. And again, we are making use of put function to convert the numeric date value to character date value. At the same time, as we were asked to check for or use the earliest date from a which dosing happened. So we are filtering only those rows where the quantity is greater than 0. And then, so as there could be multiple records within a patient, so we are supposed to pick the earliest record or the earliest date. So for that we are sorting the records based on study PT and IPSTDT, and then picking the first record for each patient. So effectively in IPSTDTC dataset we'll get one record per patient, and the date value in that will be IP earliest IP exposure date. So in the next step, what we are doing here is we are using enrollment dataset and creating a dataset called ENRL01. So in this we had two date components. One is ICDT raw and the second one is RANDT raw. ICDT raw becomes an input for RFICDTC, and RANDT raw will have to be used as a component in the derivation of RFSTDTC. So here we are creating ISO versions of those two date variables. So checking if ICDT is not missing, and then we have used nested function here. So in the previous step we have done this ISO DTC conversion in two steps, but here we are using nested functions, so and then creating it in one step. So first we are trying to convert ICDT raw to numeric component, and then use that numeric component to uh, convert it into YYMMDD10 format on the same line. Similarly, we are doing it for RANDT on this line. So first convert it into numeric format and then convert it back into YYMMDD10 dot format. So YYMMDD10 dot format is equivalent to the ISO 8601 notation when we only have date value. So when we have time component, we'll also have to concatenate time to this structure of YYMMDD10 dot in addition. So, but here in this case, we only have date. So as YYMMDD10 dot is equivalent to ISO 8601, we are making use of that. So RANDTC and RFICDTC are created. So in the next step, what we are doing here is we are creating RFENDTC variable. So for that we were asked to use EOSTDT raw from EOS dataset. So similar to the above processing, we are converting it into ISO 8601 notation and keeping only the required variables. And in the final step, what we have done is we have merged IP STDTC enrollment dataset and EOS01. In this enrollment, we have both RANDTC and also the RFICDTC. So, and for RFSTDTC, we were asked to check two components. So, if subject to at least one dose, we were asked to populate RFSTDTC using that IPSTDTC. Otherwise, we were asked to use the randomization date. So, RANDTC is being assigned to RFSTDTC when IPSTDTC is missing. So, we are checking if it is not missing. When IPSTDTC is present, the value from IPSTDTC goes and sits in RFSTDTC. Otherwise, the value from RANDTC will be assigned to RFSTDT. And in the final step, we are keeping only the study, PT, and the derived variables. So let us go to the R programming explanation now. So let us pull the R tidyverse program here onto the left hand side, and the intermediate datasets that get created from this R program on the right hand side. So say like in the previous videos, I have my data stored in this program called task SDTM Gen 74 data. So I want to have all those data sets generated within this SAS program. So I am including or calling that R program using source function, so that all the source code available in this file gets executed and the datasets will be available for my downstream processing. So source function is equivalent to %include statement in our SAS. So here what we are doing is we are creating RFICDTC. So we are using enrollment dataset. So unlike in previous videos where I have first created the numeric version and then converted the date value to character, so I am similar to what we have done in the SAS program. So we are using inline or nested functions to convert the raw date value into numeric first and then converting it into character within the same using nested functions. So here we are creating using enrollment dataset, we are creating RFICDTC dataset and passing the enrollment dataset into mutate function to create some new variables. That newly created variable is RFICDTC and it is being created as. So here we will have to first read this argument. So we are making use of asDate function to convert ICDT raw to a date value, and we are specifying that our dates are organized in the form of the day value and followed by slash and the 3-character abbreviation for month followed by year, and the delimiter between them is forward slash. So if we take a look at enrollment dataset ICDT raw, so the date values are arranged in the same format. So we are instructing SAS that my date values are structured in this way, so use this structure and convert that into a date value. And after converting, that resulting date value is being passed into another function called format. So this is kind of equivalent to our put function. So in put function we specify the numeric date values as the first argument and then specify the format on how we want to structure our output value. So similarly what we are doing here is, so the numeric date value is passed as the first argument, and we are telling format function to convert the date values into this structure YMD. So this RFICDTC will be now available as a character variable, but the date values are organized in this structure. So let us take a look at the RFICDTC dataset that is created. Where is it? I think I have not outputted it, but we have it. So here RFICDTC we have structured it, and it is now in the expected notation of ISO 8601 format. So now, and we have also passed that resulting thing into the select function to keep only required variables. So similar processing is done for RANDTC, but using RANDT raw from enrollment dataset, and the newly created variable is named as RANDTC. And in the next step what we are doing is, so we are converting the IPSTDT raw to ISO 8601 notation. So here we are not subsetting the earliest record, so we will do that in a subsequent step. We are just converting the existing IPSTDT raw variable to ISO 8601 notation, like using the same approach we have discussed for RFICDTC. And then same approach for EOSDTC using EOS dataset and EOSTDT raw variable, and keeping only the required variables. So as there could be multiple records per subject in IP admin dataset, so we are filtering only those cases where IPSTDTC is not is equal to missing. So additionally, I think we should have added that condition of IP quantity raw greater than 0 as well. So and then grouping the records at study and PT level. So and then filtering, arranging the records based on study, PT and IPSTDTC, and then filtering the first record within each patient so that we get the earliest date of each subject. So sorted the records based on study, PT and IPSTDTC, and then filtering the first record within each patient. So this is kind of equivalent to our first.pt, and then keeping only the required variables. And then in the next step what we have done is we have fetched all the date variables into our demo dataset. So RFICDTC, so to demo dataset we are joining RFICDTC. So as discussed in one of the previous videos, unlike in SAS wherein we can merge more than 2 datasets within the single merge statement, we will not be able to do that directly using the left join, right join, or joins concept, join functions in RTidyverse. We'll have to merge only 2 datasets at a time. For that, what we are doing here is we are using demog dataset, and to which we are merging our RFICDTC first, and to the resulting dataset we are again left joining our RANDTC dataset, and then again further left joining it to IPSTDTC and EOSTTC so far, and on all the cases we are using the by variables as study and PT. So whenever there is no record for a subject present in any of these datasets, so and the subject is exclusively present only in demog, what will happen is the resulting variables which are coming from these right hand side datasets will have the value of NA assigned to those variables. Say for example, if a subject is not randomized, so but present in demographics dataset, as RANDTC is coming from a second dataset and there is no record for that subject in RANDTC dataset, the value for RANDTC would be set to NA. So in SAS, missing character value is considered as NA null character string is considered as a missing value, but in R, null character string is not equivalent to NA. So by default, for the subjects who do not have a row in RANDTC, the value would be set to NA. So we are setting all the variables which have all the newly created variables which have NA to null character string here. So this syntax is kind of like equivalent to our arrays function here. So what we are doing here is we are telling that so across all these variables RFICDTC, RANDTC, IPSTDTC, USDTC. So this is kind of defining your array statement with 4 variables, and then this tilde function gives us the statements that have to be processed or function that have to be applied on all these 4 variables. So this syntax has to be read as so is NA of RFICDTC for the first instance. For the second instance, it is RANDTC, and third instance it will be IPSTDTC and USSTT. This is kind of you are looping it 4 times using your do I is equal to 1 to 4 kind of thing. So this I have created a separate video for this explanation as part of SAS and R video series. So what we are doing here is so we are checking if each of the variable is NA, and if that is the case, we are replacing it with character null string. Otherwise we are using the value from that variable. So this dot has to be read as the variable in each instance. So first time it will be RFICDTC. So when the code is being run for RFICDTC, this dot gets converted as RFICDTC. For RANDTC, this will become RANDTC. So is NA of RANDTC? If true, then make that value as character null string, otherwise use the existing value from RANDTC. So we have replaced all the NS with all the derived variables with missings here. And in the next step, we are passing that all date 02 dataset to mutate function. So we know that ESDTC is nothing but our RFENDTC. So we have assigned that. And RFICDTC, I think we have created it with the same name when we converted it as into ISO 8601 notation here. So there is no exclusive assignment needed here, but for US, as we have created it as USDTC, so we are assigning it to the RFENDTC variable. And for RFSTDTC, there was a condition for the subjects who took a who has exposure start date, we'll have to use that, and otherwise we'll have to use RANDT. For that we are making use of if else function. So we are checking if IPSTDTC is not missing or not character null string, and then if that is the case, we are using the value of IPSTDTC for RFSTDTC. Otherwise, if this condition is false, we are asking it to use the value from RANDTC for RFSTDTC. So now we have met the condition of to use if wherever the subject took a dose, they will have IPSTDTC populated. For those subjects, IPSTDTC will be used. For all the others, the RANDTC will be used for RFSTDTC. And in the final step, we are keeping only the required or the derived variables along with the subject variables. So this is how we can replicate RFICDTC, RFSTDTC, and RFENDTC derivation using our R program. So let us take a quick look at the output generated from did I not save the output? That's fine. I think we'll have all the required variables in DM01 itself. Let's cross check that way. So let's see the RFICDTC variable in the output for these subjects. So we have for the first 2 subjects it is missing, and for all the other subjects we have it populated. For third subject it is 3rd Jan and 5th Jan, 25th Feb, 2nd March, 15th April, 27th June. So we have this matching. And then let us take a look at RFICDTC. So 1st Jan, 1st Jan, 1st Jan. So there are 3 subjects who signed the informed consent on 1st Jan 2010. In fact, there is a 4th subject who also signed. And then 15th Jan, 18th Feb, 15th Jan, 18th Feb, 4th April, uh, and 20th June, 4th April and 20th June. So this is also matching, and the final variable that we created was RFENDTC. So let's see that. So here 5th Jan and again 5th Jan and 28th Feb, and for 1005 it is missing, so it is the same case here. And then 25th March, yes, 12th June, yes, and 18th August, and then 18th August. So we are actually matching on the values for all subjects as well with the programs which we have used with SAS and also in R. So thank you for watching. Keep learning.